This is problem number 3. There's a straight road leading from the town of Westboro, that I will call W, to a grid town, A, 30 kilometers east and 10 kilometers north. Partway down this road, it junctions with a second road perpendicular to the first. So we're going to be dealing with perpendicular lines here. Leading to the town of Eastboro, which I'll denote as E. If Eastboro is 20 kilometers east of Westboro, how far is the road junction from Westboro? So a lot of information here. Best thing here, especially with questions where you have things that are positioned in space, is to draw something just to identify where everything is. So I would say that for this problem, stay with me. We'll draw the diagram together, and then I'll give you questions to answer that will take you to the answer eventually. And then I'll tell you, like, pause now and do the question, and like answer this question on pause when you think you have the solution, and then I'll give you another question to solve. Okay. So we'll start by drawing on a diagram all the information that's given here. So we've got a town, Westboro. Okay, now we're going to have to position it in the Cartesian, well, in the plane, but let's use the Cartesian plane. And why not like use east-west along the x-axis, south-north along the y-axis. Okay, so like this is going to be east, this is going to be north, this is going to be west and south. So I'll since we start by positioning Westboro, why not just place it at the origin? You could place it anywhere you want to, but why not just at the origin? It might be just easier like that. Okay. I was not able to get the Westboro right on the origin. Okay. I'll just make it. Okay. All right. So Westboro is in 0, 0 right now. Let's take, let's identify where a grid town is. It's 30 kilometers east, so along the x-axis, and 10 kilometers north, so along the y-axis. So it's going to be somewhere here. That's a grid town, which is at 30, 10. There's a road connecting them, a straight road. Okay, so maybe I'll just... Okay, that's the road. And partway down this road, it junctions with a second road perpendicular to the first, leading to the town of Eastboro. So maybe let's identify where Eastboro is. Eastboro is 20 kilometers east of Westboro. So it's going to be here, 20, 0. It's kind of in the middle of W and A, because the x coordinates, look at them, they're 0, 20, 30, so it should be a little bit left of A. And basically there's a road leading from the junction to Eastboro, making a right angle with the other road. So these two roads here, they make a right angle, and we're trying to find, well, not the junction. Well, we're going to need to find where that junction point is, but we're trying to find how far is the road junction from Westboro. So practically speaking, that means we're interested in finding this distance here. We need to know what that is. So this is what we're looking for. We're looking for D here. Okay. So obviously a lot of things to take care of here. I probably need to know what those green lines are, and by that I mean their equations. With that I can probably get the junction point, and once I have the coordinates of G, I can use a distance formula to calculate the distance between I said G, but J and W. Okay. So let's start with trying to find the equation of the road going from Westboro to a grid town. And that's going to be our first question here. So write an equation for, now that road is a line, right? So a line passing through W and A. So that's the first question I want you to answer. So pause, do that part. So write in the form y equals mx plus b, something like that, and unpause when you think you've got the answer. So for that line, I need the slope, right? So I'm going to do delta y over delta x. So 10 minus 0 over 30 minus 0. So that's easily 1/3. And it goes through 0, 0. So the y-intercept is 0. So the equation of the line is simply y equals 1/3 of x. So now, obviously, we want to get the equation of the line passing through J and E. Okay, notice we don't know what J is, okay? So you can't use delta y over delta x to find your slope. You're going to have to find the slope in some other way. Okay, so pause and come back. So now the slope here is actually, since it's perpendicular to the previous line, it's going to be the negative of the reciprocal. So minus 3 here, right? Or the reciprocal being 1 over 1/3, but that's minus 3. Okay, in other words, that's minus 1 times 3 over 1, so that's minus 3. So that's our slope, and this time it has a y-intercept that's non-zero. So I'm going to use the fact that I have a slope and a point, right? E being the point. So I'm going to write my equation in point-slope form. So minus 3 x minus the x-coordinate plus the y-coordinates, which is 0. So that's going to be what? Y is minus 3x plus 60. Now that we have our two lines, probably we can find the intersection of those two lines. That's our next question. We'll find the coordinates of J. Okay, so here what we need to solve is we need to find a point that's part of both lines. So it needs to be part of the, well, this is the second line and the first line. Okay, so it needs to satisfy both equations. So it's a system of two equations, two unknowns. We can obviously maybe just identify or equate the right hand sides. So since the y's are the same, so minus 3x plus 60 should be equal to 1/3 of x. Maybe I can just clear the fractions here, like that. Send so add 9x on the other side, so I get this. So x is 18, and now that I have that x is 18, I can just replace in any of the two equations I have here. So maybe just the second one is easier. So y is 1/3 of 18, so it's 1/3 of, well, that's actually 18 divided by 3, so it's 6. So J is the point 18, 6. Okay, so I can go back on my diagram. This is 18, 6. Makes sense, right? It looks like it's a little bit, well, it should be a bit less than 20 for the x-coordinate, and obviously between 0 and 10 for the y-coordinates, so it makes sense. And now to find D, I need just to find the distance between the J and the origin. So in other words, it's the distance between 2 points. So that's our last question. So find the distance between J and W. So the distance, what is it? It's the square root of the difference between the x-coordinates squared and the difference between the y-coordinates squared. It's the Pythagorean theorem. I'm not going to re-explain it. There was a section where we reviewed the distance formula. So this is how it's obtained. So we subtract the x-coordinates, subtract the y-coordinates, and calculate this. This is going to be 18 squared plus 6 squared square rooted. So this is approximately, using a calculator, 18.97 kilometers. And here we go. We've solved that problem.